Why is it that your AI systems look absolutely flawless in a completely controlled sandbox demo, but then fail spectacularly the literal second they hit real-world production? I mean, why do enterprises waste months debating GPT versus Claude, only to end up with massive failures and exactly zero return on investment? Well, today, we're skipping the fluff. We're diving straight into Databricks technical lead Sandeep Bhaumik's frontline playbook for actually deploying enterprise AI agents at scale.
Look, we're all falling into this Trojan horse trap, right? In the demo phase, everything's great. You've got predictable data, perfectly controlled scenarios, and leadership is patting you on the back, giving high praise. But out there in production, that's where you get hit with unpredictable real-world data, massive but silent failures, and absolutely zero ROI. It's brutal.
Which brings us to the exact, direct question every single AI engineer is facing today with extreme urgency. You put an agent into production, and 3 weeks later, leadership comes knocking, asking, what on earth is this AI doing? Why isn't it answering questions like it did in the demo? So to solve this engineering nightmare, here's the exact roadmap for this explainer. First, the AI demo illusion. Then, bridging the 3 gaps, laying the data foundation, handling orchestration and governance, looking at a real retail banking case study, and finally, the production incident playbook.
Okay, section 1, the AI demo illusion, why POCs fail. Let's dissect why all that leadership excitement over a sandbox demo just completely evaporates after deployment.
According to Sandeep's Frontline Insights, it's because organizations plunge headfirst into a valley of despair created by 3 critical gaps. First, the observability gap. You simply cannot trace why the AI made a certain decision. Second, the evaluation gap, meaning you have no continuous, metric-driven way to actually measure success. And third, the governance gap. When your AI hallucinates at 3 a.m., there's absolutely zero accountability. Moving on to section 2, bridging the 3 gaps, evaluation and observability. These are the foundational pillars you must build before a single line of application code is written. You see, evaluation isn't just subjectively asking, hey, is this accurate? It requires 3 strictly defined architectural layers. Number 1, deterministic. These are your basic format and PII checks. Number 2 is semantic, which checks for groundedness. And number 3 is behavioral. Think about it. An AI might give the right answer about an account balance, but under the hood, it got stuck in a loop and made 3 duplicate, highly expensive API tool calls to your database. You have to monitor and catch that. So how do we solve that semantic layer at scale? We use LLM as a judge. This is where you utilize a secondary, heavily prompted language model to autonomously evaluate your primary model's outputs. It checks for safety, relevance, and accuracy against a golden test dataset. It's basically automating your quality control. And that perfectly tees up observability. Sandeep put it best. If you cannot trace every decision, it's no use in production. This isn't just some nice-to-have best practice, folks. It's the black box flight recorder for your AI. It's strictly mandatory for European regulators, and it's your absolute lifeline for rapid incident resolution. Let's transition to section 3, the data foundation, preparing for unforgiving agents. Believe it or not, this phase consumes a massive 60% of enterprise project time. And here is exactly why data quality matters more now than ever. Humans are forgiving data consumers. If we spot a wrong number in a report, we figure it out, we forgive it, and we ask someone to fix it. AI agents, they simply do not forgive messy data. They will silently ingest that bad data and output confidently wrong answers. It's terrifying. Okay, section 4, orchestration and governance, scaling from one agent to many. A single agent is simple enough, but what happens when you scale to an entire ecosystem? That requires serious control. You basically have 3 exact multi-agent coordination patterns to pick from. First, the orchestrator worker pattern. This gives you centralized control and distributed tasks, making logging easy, but the trade-off is higher latency. Then you have choreography. This is autonomous and event-driven, relying on a message bus for parallel processing. You get rapid, low latency, but logging becomes much harder. Finally, human in the loop. This provides threshold-based human fallback for the highest possible safety, but obviously it runs at the lowest speed. And to manage these multi-agent systems without crashing, you need essential AI governance constraints acting as your brake system. You absolutely need mandatory regulatory audit trails for every single API call. You need pre-validation layers. In fact, in one project alone, this caught 47 PII breaches in testing before launch. You also must treat prompt versioning strictly as enterprise code change management and systematically test model upgrades against your own dataset. Now, Section 5, Retail Banking Case Study from Failure to 60% Deflection. To prove this isn't just theory, let's look at a hardcore, real-world bank that was managing 20,000 monthly customer support calls. $85,000. Let that sink in. That is the exact sunk cost this bank completely wasted over 6 months on a failed proof of concept. And why did it fail? Because they entirely lacked the measurement and observability pillars we just talked about. So the expert team comes in and completely flips the script. Observe this timeline closely. It's brilliant. Weeks 1 and 2, they didn't even touch the LLM. They built a 200-case human-validated evaluation dataset. Weeks 3 through 6, they engineered automated tracing and deterministic evaluation pipelines. They literally waited until week 7 to finally execute model selection against their live test dataset. And guess what? They ultimately achieved their 85% accuracy target. Which brings us to our final section, Section 6, the Production Incident Playbook, Surviving Failures. Because let's be real, the AI will inevitably break in production. Like when outdated interest rate vector embeddings crashed this very bank's customer satisfaction scores. You have to have a strict playbook. Step 1, detect. Spot the anomalies via your evaluation dashboard. Step 2, diagnose. You have to trace the specific agent steps and API calls to find exactly where it went wrong. Step 3, contain. Apply your circuit breakers or immediately deflect to a human. And step 4, fix. Update the prompt or the data and crucially add that exact failure to your living test case library so it literally never happens again. Let's rapidly review the core hard metrics and specific facts we extracted directly from today's enterprise OI breakdown. Target deflection rate reached 60% of simple user queries. Failed POC sunk cost, $85,000 wasted over 6 months. Evaluation layers, exactly 3. Deterministic, semantic, and behavioral. Security pre-validation, caught 47 PII breaches before launch. Model selection timing, strategically delayed all the way until week 7. And that initial test dataset, 200 human-verified cases. If you only take away one single underlying logic from this explainer to implement tomorrow, make it this. Model selection is the final, easiest step. Long-term AI success relies entirely on a pre-built foundation of continuous evaluation, tracing, and data governance. Now, I've got a hardcore debate for you. Is intentionally delaying your AI model selection all the way to week 7 a genius architectural design, or is it a massive trap that just slows down your iteration? I want to hear your exact take on this specific controversy. Drop your arguments in the comments below. And while you're down there, type "leave a comment" right now to claim the complete production incident playbook and the enterprise evaluation checklist from today's explainer. Keep building, and I'll catch you next time.